Hello, I was playing my Rubik's Cube. Did you know that a Rubik's Cube actually has approximately 43 quintillion permutations? That's insane! And did you also know that you can actually use the group theory to solve the Rubik's Cube by finding its solution? But why is it called the group theory? Well, when we define a group, it is basically a set with operations that uses two or more elements of the set where they are combined to produce a new element of the said set. A simple example of a group is what we know as the Albanian group. This is found in basic algebra, where its law of composition is commutative. This means that examples like x times y equals y times x, I can define this as a group because it has a set as shown, x and y, those are the elements, and operation used was multiplication. And since groups are sets with restrictions, therefore it is natural for them to have subsets. If we look at it deeper, groups are followed by a set of integers or any collection of elements that follow specific group axioms 1, 2, 3, and 4, namely associative, identity, inverse, and closure, respectively. Upon extensive research, the associative axiom or axiom 1 states that in any single group operations, adding parentheses anywhere in the equation will always yield the same result. So, an example relating to the Rubik's Cube is the number of turns. Say turning the top layer 2 times to the right and then 3 times again to the right is basically the same as turning it 3 times first to the right and then 2 times. In other words, using equations, say 1 plus 1 plus quantity 1 plus 1 plus 1 equals 5, is still the same as quantity 1 plus 1 plus 1 close quantity plus 1 plus 1 equal 5. Next is axiom 2, the identity axiom. It is basically an element, say that's element x, in a group where when applied to any other element, say it's y, it still results in element y. This means that the element x is like a zero or a ghost element. Like turning the top layer does not change the element of the colors of the top layer. It's still white. On the other hand, axiom 3 or the inverse axiom is like an element in the group when added to another element yields to the identity element or simply 0. It's like this element cancels out other elements. And axiom 4, closure axiom, is said to be group operations that must be closed or restricted to only group elements. Simply, this means that there are only limited elements in a group such that they are the only elements present in other groups as well. In simpler terms, say that this is a group in a Rubik's Cube and this is another group. So the colors per group is the elements that are close, because in a normal Rubik's Cube, there will always be just 6 colors representing the 6 sides of a cube. So overall, we learned that the group theory has many applications by using the 4 different axioms: associative, identity, inverse, and closure. We have our own ways or patterns to go to school, and this relates to axiom 1, associative. Any way we choose any route, we will still all arrive in the same destination, which is school. We bring our everyday school supplies such as laptops, notebooks, etc. Pens, thus action 2, identity. So, relatively speaking, not only can the group theory be seen in the mathematical perspective, it can also be seen in our daily lives. That's all. Thank you.